want me to expand it out a little more? You're good? Okay, so let's choose a different alkene. Let's do, I don't know. Let's do cyclopentane. And then what's our reagents in any order? What are we going to be using? Osmium tetroxide. So that's one of them. All SO4. And then we have sodium thiosulfate, NaHSO3. And there's also some water floating around. And water is used to make these OH groups you want in the final product, which are going to look like this OH addition.
So for the final product, are we supposed to kind of just memorize what that is?
Yes.
All right. Or he'll take it to us on
I would memorize all the final products for every reagent, for sure. Okay. This reaction, again, it's a really weird one. So it's something where I'll try and point out to you when something strange happens and maybe try and remember at this point there's a weird thing. What weird things do I know? If that makes sense. So we're reacting a cyclopentene with osmium tetroxide, which structure is just osmium double bonded to 4 different oxygens. So it's osmium, and each oxygen is bonded to is with a double bond. Okay? And this osmium is going to form a cyclic structure with cyclopentene. And these 2 oxygens were part of that cyclic structure we're going to form. So what happens is our nucleophilic double bond attacks one of the oxygens on osmium. But when it does that, this oxygen wants to get rid of electrons, so it pushes one of these bonds onto osmium. Osmium then doesn't want those electrons, so it pushes these away. And then once oxygen gets an extra pair of electrons that it doesn't want, it decides to form a bond over here. So it's 2 bonds forming simultaneously to form a cis ring to osmium tetroxide. So it's going to look something like this. So these are the cis oxygens that are part of our final product. So these are always going to be there. They're bonded to osmium, which is still bonded to these 2 double bonded oxygens. All right. What we want to do with this reaction is to, at some point, protonate these cyclic oxygens to get OH groups, right? And you're going to protonate once with your acid, and then you're going to protonate the second one with the water. And you're also using water to push this osmium off eventually. It's used to cleave osmium. So the first thing we're going to do is use this acid, HSO3. Well, I'll use a different color just so it kind of sticks out. And then one of the lone pairs from one of the cyclic oxygens is going to protonate itself with the acid to look a little closer to our final product. So we're going to start forming an OH group on this oxygen by taking a proton off of acid. That's really acid's only function is to protonate things. And then eventually it's going to start deprotonating other things.
So question, the bottom O on the left one, does that have 2 electrons inside it?
Yeah.
I just want to make sure it's
That's good catch. Always good to draw as much information as possible. Yeah. Unless I drew it wrong, I think HSO3, it must be H2SO3. I might have just, does anyone have the reagent available to them? Either way, it's used to protonate. So sorry. Also sorry that there's no space. You can sit up on one of those if you want.
H2? No, it's HSO3.
Is it HSO3?
With 2, it's H2SO3.
Hopefully he's not testing you on your 104 knowledge. These reagents are most likely going to be given to you. But that is HSO3's function. Okay? It's used to protonate one of our oxygens to start getting closer to OH. And when we do that, we're going to have this cyclopentane. Still has these cis oxygens, still bonded to the cyclic form of osmium. We'll draw the rest of the junk. But now this oxygen has a hydrogen, which is good. We want that to happen because it's that much closer to becoming a hydroxyl group. The only problem is it can't be a hydroxyl group if it's osmium bonded to it. So we're going to use water to cleave a bond off of osmium, right? So we're going to bond onto osmium with H2O and cleave this bond here. So I'll use blue for water.
So there's supposed to be a charge on the OS?
Oh, yeah. So on this, what charge is on oxygen here? Positive. Not entirely sure what the charge is on osmium.
It doesn't matter.
Yeah, it's not super. And it's so many electrons. I'm sorry, I don't have it memorized. So we have oxygen here. Sorry, it's being a little crowded. So once we're close to OH, we finish the job. We finish making the hydroxyl by bonding this water to osmium. And when we do that, it cleaves off these electrons, stabilizing that positive charge. And then we're that much closer to our final product. We finished forming one hydroxyl group out of two. So we're going to have something that looks like this. Sorry if I'm in the way. Okay. Really important to keep track of all this stuff in your reactor. So again, if water adds to anything, it's going to become positively charged. Once it becomes positively charged, it's going to want to get rid of a hydrogen to stabilize that charge. So we could use water or acid again to protonate this oxygen, just like we did for the previous step. But this water is so much closer that we're just going to do a proton transfer, like you said in lecture, and just take a proton directly from the water that bonded. Because that not only gives us the OH we want, but it also stabilizes this positive charge. Okay? So we bond with water, and then we use this oxygen to protonate from this hydrogen. So we take this lone pair, take that hydrogen from the water, and then this stabilizes water's positive charge.
With the, wait, just really quickly, when we write that like the plus sign to the water that we just had over there, do you have to draw like the other two electrons?
You can if you want.
I just wasn't sure.
It's I would always say judge how much time you have.
Yeah, we were just discussing it earlier when we were trying to.
But it's always good. I mean, these are all graded on partial credit, so the more stuff you have, ideally the more partial credit you get. So, all right, so I'm going to extend each. Hopefully you guys can still write what you're needing to write. A quick drink of water.
So what's happening in that last step with the arrow?
So the way I like to look at it is that you're doing the same thing you did here. You're just protonating the oxygen to get an OH. So yeah, this one's a lot closer.
Ripping the bond from the hydrogen to the oxygen, giving that to the oxygen to use it out.
Yep.
And then taking the hydrogen and hooking it to the O to give us.
Yeah, because then we're that much closer to OH.
Gotcha.
Which is good. Apparently. All right, so we have our cyclopentane, and this is now 60% done. We have OH, which is good. Now this oxygen has a hydrogen on it, which is going to give it a positive charge, and then we still have this osmium, but it's now bonded to double bonded oxygens, and that OH, which is a result of taking the hydrogen off of water. I believe it does have a charge at this point. Nope. So osmium is still chargeless. Okay, so what did we use to cleave that bond off of osmium before?
Water.
Yeah, we used water. So if we want to get rid of this bond, we're just going to use water again. We're going to bond water onto osmium to cleave this bond off. So I'll use blue, and will be kind of up here, so sorry. A little harder to see. But just like we did for the first bond, this osmium is going to get bonded onto by water, and then once it gets that extra electron stuff, it's going to break this bond off onto oxygen. And then that gives us our final product. Again, for this reaction, once you have your final product, that's really all you need to show.